thank you again, those of you who sent some examples before today. I've kind of put them together on some slides, and I thought what would be really helpful is if you guys wouldn't mind just talking a little bit about what you sent and about how what the activity was that you were doing, because I asked people to send an example of things that worked well in a remote setting in maths, because obviously at this point we're kind of pivoting a little bit and doing things a little bit differently. And I think it's kind of important to think about what the key differences are between the way that you teach when you're having to teach predominantly remotely, and how that might affect the way that we teach sort of going forward. So Jack, would you mind starting us off?
Yeah, no problem. Hi everyone, I work at Garden House School in central London. So one of the approaches we took is we wanted to make it as practical as possible. The children were sitting at a computer we did quite a few live lessons, so that our children were at a computer for a good chunk of every morning. So wherever we could, we tried to change it up a bit. And this was one of our lessons on Venn diagrams. We were doing Venn and Carroll diagrams. And we decided to let the children be a little bit creative and go away and create their own Venn and Carroll diagrams using things around the house. They were actually probably more creative than we thought they'd be. I mean, like the tennis racket idea was a really good idea for creating the circles for one of the Venn diagrams. And just basically giving children a bit of ownership over their learning rather than us giving them a set criteria. They could actually have a bit of freedom, and they really enjoyed it. As you can see, some children got outside as well. So yeah, it was a really useful activity for them. Another approach we went with was trying to link it as much as possible to other subjects. And so we just finished doing a geometry topic, and we'd found an artist called Kandinsky who's uses a lot of geometrical shapes in his art. And so we showed the children some examples of the art, and then we gave them set criteria. For example, your artwork has to include at least 2 obtuse angles. It has to include at least 5 different shapes. You have to have perpendicular lines in your artwork. And again, it was a great way of just assessing what they knew, what they'd taken from us, whilst them not really thinking they were doing maths. And actually they thought they were probably doing an art lesson, but it was a good way for us to see who had picked up what we'd taught them. And finally, I think it's probably for all of you, just using technology wherever possible. We quite often use Quizy as a form of assessment because it was quite hard to assess where children were over the remote period. You were getting a lot of help from certain people at home, especially we've got lots of nannies that were sat around their children. So it's quite hard to, so using a live Quizy, when I could see the children on screen and I could see their instant replies, was a great way of going through it and then reviewing some of their answers live there to see what the misconceptions were. So that was one of the websites we used. We used many. And then the bottom one is from MathSpot, which is a great website for using manipulatives. Certain things that we would have had in class, I couldn't guarantee children had at home. So that way, by at least using that on my screen, they could visualize those concepts rather than be completely abstract, which they need. Year 3, so we're kind of getting to that stage where they are using abstract a little bit more, but we obviously want to keep it as the manipulatives involved as well.
Great, thank you so much, Jack. Those are really, really creative examples. And I think maybe actually before we move on to the next one, I'd give people a little chance in case anybody wants to make comment or ask any questions about what about those activities. Well, I will make a comment, which is I really, really like the Kandinsky idea. And actually, it's interesting. There might be something that pops up a bit later on that kind of links with that a little bit, which
okay, great.
That later. But yeah, I really like the idea of kind of using rules to create art and that being kind of mathematical. It's my kind of subject area passion is computing, and it definitely, there's a lot of links that you can make in that area. So thank you for those examples. Cool. Okay, should we move on to the next one? I think it's Katie's next.
Hi, I'm a Year 6 teacher at Hitherfield Primary School in Streatham. I'm the maths lead. So yeah, Year 6 obviously quite different from the Year 3. We didn't do any live lessons, so we had to record videos of ourselves and then send them attached to the work that we were sending the children. But we did things like a starter task for everyone to access. And because we've got a variety of children ability-wise ranging, so in my class ranging from Year 2 in ability to exceeding Year 6. So I've got such a wide range. But we'd have a separate SEN activities for those children, but really the main cohort, which who are probably working between year 4 and year 6, would be accessing this. And we would do things like having a starter task for everyone, just to get them almost warmed up and feeling sort of a little bit more confident about things before then moving on to the next. Then we'd have 3 levels, and it was completely up to the children where they started. So it would be, they choose their level based on the starter task, based on how they felt about, so for example, fractions, decimals and percentages, about that maths topic. And it was interesting, you'd have some of the higher ability who you'd expect to go straight to level 3. Some of them were really struggling just with working from home and just just missing their friends and everything. So that I found that they would start at level 1. They didn't want to be involved. Whereas others were challenging themselves more, that maybe would normally stick to a level 2, felt quite confident, would move on from level 2 to level 3. But also it just gave them that option. So it was really nice to be able to say, you start where you feel comfortable. And if they were feeling quite confident, they could move up a level as well. But also it gave them a bit of an option to self-assess. And some of them who you would expect to be pitching themselves in the middle, I spoke to parents, we spoke to them quite regularly, would have a little breakdown and had been crying. So they stuck to level 1 just to build up confidence. And that seemed to work well. Obviously it's computer based everything on the laptop as well. We did use MathBot as well, Jack. So I found that really useful in the teaching videos and for everyone in the school to use, to make sure that you're using the correct language, or showing things correctly and modeling correctly as well. So that's kind of how we did it. Some options. So should I do another one? Oh yeah. Then you could move on to extension thinking. Any level could access that. And just have a go at seeing how they felt about it as well. So
cool, thank you, Katie.
Thank you. Thanks.
I think that's the last one. Cool, thank you. Great, and thank you for sharing so many examples as well. I think what you mentioned about sort of the children having the ability to self-assess is a really interesting point, and it's something that I think has come out of a lot of discussions that we've had with teachers sort of over the last year or so, about kind of those sorts of attitudes towards learning and ability to kind of I guess it's kind of having a growth mindset really, but like independently take responsibility for your own learning and it not necessarily impacting your self-esteem negatively.
I think the maths anxiety, I did see a big increase in that, and I've been looking, sort of doing staff meetings and looking around that, reading articles around the maths anxiety, just because it's just become I think it's just grown in lockdown and from being at home. Some of the children we'd communicate via Seesaw, so the learning platform, and they could send voice notes and they'd be like, I can't do this anymore. Whereas in class, that they'd feel more confident. That anxiety has increased. So it's been a big thing that we're looking at now with return, to really address those issues too.
That's a really interesting point. If you happen to have at your fingertips anything in particular that you've read that you think would be worth sharing, that would be great. Or you can stick it in the chat if you want, and then we'll put it in what we send after today. That would be really great. Thank you, Katie. Cool. Okay, Laura.
Hi. So I'm a year 6 teacher, a maths teacher, and maths lead. So I thought that mental strategies really picked up. So it is kind of, we were in different mental strategies, and then in the top right-hand corner, Kahoot, there's a quiz which I think might be like the other one that said it's similar to that. So the children really loved using Kahoot, and it's competitive, and the points, there's a leaderboard, so we used that quite a lot as well. And then bottom right, you've got a purple mash quiz. There they had the questions, they could go through the questions. They didn't have to show their working out, they didn't have to those things. And actually this week, when we've been back in class, I've seen them using those a bit more as well. So that's bringing that in from online learning as well. So
Great, thank you. Kahoot is definitely a tool that I think we were already quite big fans of at the CLC, but it really seemed to come into its own during, I think, like it kind of giving a sense of being in a place together, doing a thing together was quite powerful, really. And a lot of people seem to be big fans of that. Okay, cool. We also have Billy with us. Now, Billy, sorry to pounce on you. Is there anything that you would like to share about your own reflections on this question? I know that I haven't got a slide for you, but I guess the question was what worked well in maths during while children were learning from home. And I know you've already sent us examples of assessment in answer to this question. But do you have anything that you'd like to talk about teaching maths?
Well, I'd say it's very similar to what everyone else said. I think self-assessment played a big part in it. So we would send out videos in the morning of us teaching the maths, and then videos would go out every afternoon, breaking down each questions, explaining different ways, but also we had daily check-ins on Zoom. And we tended to spend the first few minutes of those talking about any maths issues from the day. I think while other subjects, some of the feedback was much more personal. So it's like in English, your feedback would be more personal to each child, whereas with maths, it tends to be sort of if one thing is hard, it tends to be the majority of the class got it for some reason. So I think it was usually maths that became the talking point in our Zoom sessions. But yeah, like everyone else said, self-assessment, trying to be as creative as possible, trying to get in as much manipulatives as possible, although that was a real struggle. I'm a big fan of MathSpot as well for those resources, because especially for my SEN children, who counters and things like that are how they access maths day to day. For that to have disappeared was a really hard thing for some of them. So the manipulatives are so important. Yeah, I think that's it.
Great, thank you. Yeah, thank you for sharing. And it's interesting that there are a few sort of common themes from different schools. So I'm going to hand over to Peter now for the next bit, where we'll share some more ideas.
Thanks for all those really interesting comments. And we've got a follow-up question, which we've tried to phrase in a more positive way. So what are you most excited about? And that's going to pick up on some of the things you've said already. And you know, it's London CLC, so there's got to be at least one Padlet. In fact, there's more than that. So we've created a Padlet, and we're going to give you a little bit of time now, if you wouldn't mind contributing. So I'm hoping that's going to link. Okay, great. I can see things appearing already. Thank you. Yeah, some really interesting comments coming up, and the one about time, I can imagine that drawing on my experience. Yeah, challenging to teach that remotely. Problem-solving activities, and I wonder if those are individual activities you're thinking about, or collaborative group work. I guess both would be worthwhile. Next up is finishing and recapping. Yeah. Plenty of opportunity for maths talk. Yeah, and those opportunities for you to assess within a lesson, and able to clear up misconceptions that you've identified before children embark on the work. Oh, that's interesting. Yeah, so linking areas of maths through investigations. Great, lots of detail on after Easter Year 6 as well. And as you mentioned already, reducing maths anxiety, and that, I guess that will be so important before going into Year 7. That's really nice. Thank you very much, everyone.
Yeah, thanks everyone. Yeah, and we'll keep hold of that link as well. So as with the other links that we use today, so that if you want to refer back to anything, then you can take a look. We'll send out a version of the slides that we use afterwards. Cool. So we thought it would be nice to do a little bit of practical stuff, as well as having plenty of conversation today. So what I've done is I've prepared a little Scratch activity for us to have a go at, which is making a quiz, making a kind of almost like a little chat bot that will do a quiz with you in Scratch. Just out of curiosity, is anybody currently using Scratch in maths teaching, or kind of linking that, like computing and Scratch in that way at all? Just
we literally oh, sorry, go ahead, go on.
We've been doing lots of computing, Scratch and computing over this lockdown time, so they're amazing, and they've been using a lot of your stuff as well, Rowan.
Oh, cool.
And creating their own. I mean, I just don't understand how they do it. Some of mine are incredible, but we haven't directly linked it to the maths though.
Cool. Okay.
Nothing. We're the same. We literally were debugging codes yesterday on Scratch with the boys, but again, I wouldn't say we've linked it to maths. It's more the coding side than the actual math side.
The only thing we've done really is part of the Horizon Not Switched On computer and scheme has them using Scratch to find prime numbers and things like that. So we did that last term, but I am looking at embedding computing more.
Yeah, cool. Well, that sounds good. Yeah, so I think for me, they're quite sort of natural sort of like kind of connections to make between computing and maths, and particularly using Scratch, because there's a lot about the way that Scratch works that links really clearly with various aspects of the maths curriculum. Things like using coordinates is a kind of a really key aspect of how Scratch works. And there are a few other things as well, and I'll kind of, what I'll do is I'll go through one example in a bit of detail where we can have a go, but I will also talk about a few examples, and I will give you links that you can use to pursue those further if you wish to, or if we have a bit more time at the end and you have questions and you want to go through anything in more detail, then we can do that too. So so there's quite a lot of, there's so much that you could do, so there's quite a lot of stuff that I could go into. Probably do a whole session on just maths and Scratch, I think, but we'll stick to the one main activity, which will be making a quiz, a kind of like a chatbot quiz. So I will just share my screen. And then we can get started. Where are we? Here we go. The first thing that you'll need to do is just think of 3 maths questions that might be relevant to your pupils. And so they need to be questions that have a clear answer, although it could be a text answer or a numerical answer. We can make either of those work. But yeah, something with one clear answer that you can type, basically, is the key thing. So have a little bit of a think about a few things that you could use. You will need 1 to get started with. The other 2 you can think about as we go along, if you like. That's the first step. And once you've got your questions, the second step is going to be to start creating your Scratch project. So if you're not already on the Scratch website, it's scratch.mit.edu. And when you're there, there's like a little menu bar at the top that has a few options on it. And if you click create, then that's just going to open up a new empty project for you. And that new empty project will have like a plain white background, and it will have a cat that looks a bit like this guy on the screen who's called Scratch. And it will be called Sprite 1 underneath. If you mouse over that cat on the right hand side of your little window, a little bin icon will pop up, and you can delete it, because we're going to choose our own characters for this project so that you can pick a quiz master that you would like to use. So once you've deleted your cat, underneath it you'll see in the little sprite area on the bottom right, you'll see that there's a button that has a cat's face and a plus, and that's the button that allows you to add your own character. If you click on it, or actually if you just mouse over it and then click on the magnifying glass, then you'll get a list of all the different characters that come preloaded in Scratch. There are other ways of adding characters. You can do things like upload a photo from your computer, you can draw one yourself. You can also take an existing one and then you can change it a little bit, or you can click, is it the star? Yeah, click the little star, and that will give you just a random one if you would rather not make the choice, which is, it's always good fun. But yeah, so if you'd like to click on the little magnifying glass and pick a character that you would like to choose to be your quiz master in our Scratch quiz. Thumbs up if you're good. Yeah, great. Thank you. Cool. So this is just, I'll just give you just a quick overview of what we can see when we start up a Scratch project. So on the left-hand side, this is our block library. So it's where you get all of the instructions that you can use to make your characters do different things. And you'll notice it's rather helpfully color-coded. So any block that is to do with motion will be this lovely shade of blue. But if you wanted to make your project make any kind of sound, then you'd need to go to these kind of pinky purple blocks over here. If you had something that was to do with operators, which maybe we will, as we're talking about maths, then you'd want to go to this green section over here. So, so that can be really helpful, because it means that if you see an example of a Scratch script, you can find you can work out where all the blocks live just by looking at what color they are, basically. So that's a little overview, and then the middle section is where we actually put the blocks when we want to program them. You may have this little window on your page if you've just started it from the Scratch website, which is just a little tutorial that tells you how to do some stuff, but you can click close to get rid of that if it's in the way. And then over here, we talked about this area already, this is where your characters in your project, which are called sprites, that's where they all live. And if you wanted to program one character, then you click on them here, but if you have another character to program, you can click on that and you'll get a different script area to give it a different set of instructions. There's also the area on the right hand side where you can switch to your backdrop. And if at some point the fancy takes you, you can also go there and add a backdrop to this project if you want. So the next bit is going to be to put our first question into the project. And so you can see the blocks that we need to use to do that. We've got this kind of yellowy orange one, which is the when the green flag is clicked block. And then we've got this nice blue one, which is called the ask block. And as you can see, I've got ask what is 3 times 4 in my ask block. So if you'd like to have a go at building this beginning part of your script, you just need to find those 2 blocks, drag them into the middle area and clip them together. And so with Scratch, these kind of yellowy coloured blocks, they're called the event blocks, and they're really important because they tend to be the things that get your program started. It's the instructions that tell your characters not just what to do, but when to do it. So this block means that my character is only going to start asking me my maths questions when I click on the green flag. And you can see above the little stage area where your character is displayed, there's a green flag there. So you can either click on the green flag on the actual block itself to test this program out, or you can click on the green flag above your little stage area, and either of them should work because that's what the program says. And anything that is connected to this block will then happen. So if you made a chain of instructions a bit longer than this, you'd see those things happen as well. And that's what we're going to do a little bit later on. So how are we doing? Have we got a green flag block and a question block? An ask block? Good stuff. Okay, so so then the next thing, and I always say before I actually go on to the next bit, I think it's a good idea. We talk about maths talk a lot and about kind of verbalizing a problem, and that allowing you to sort of think about what the problem means. And so I always think it's good to pause at this point and actually ask ourselves, what should happen next? So if this character is asking us this question, what is 3 times 4? What would we expect to happen when we start using this project? What do we think should be the next thing that happens? Well, obviously it depends what we write, doesn't it? If we write 15, maybe we might want it to say something different to if we write 12, for example. So I've kind of suggested an answer to that question, which is if the answer is 12, so if we type 12 into the box, then maybe the fairy can say correct, and that can be kind of our first option for what happens next in our program. And now that I've kind of written that sentence, now that I've kind of verbalized that idea, we might be able to have a think about where the blocks might live to make that happen. So for example, there's a really important word at the very beginning of this question that tells us that there is a block in the control section. So if you have a look at the orange control blocks, that might help us. And it's a very important block because it's a block that allows you to create a program that has the possibility for 2 different outcomes, or it can be more than 2 different outcomes actually, but more than one outcome is the main thing. And that is the if block, which is going to be really important in this project. We also might want to think about the operators that would be helpful. So those are those kind of light green blocks. And the word that's important in relation to operators in this question is the word is, because is, I guess, is kind of it's kind of synonymous with is equal to, or equals, really, isn't it? We are telling the fairy to do something if the answer that the person writes is equal to the number 12. So that might help us if we're having a look at the operators section. And then lastly, there's the looks blocks. And this is a funny one because we want the fairy to say something, but she's actually not going to say it out loud. She's going to say it in a speech bubble on screen. So that means that it's to do with looks. It's to do with the way she looks. And the kind of missing thing from that sentence that I haven't really talked about is this word answer. And the word answer is something which is attached to the block that you've already used, the ask block that you've already used, because that ask block in your program, it always is accompanied by this block called answer. And that's because the answer block does the job of storing whatever you write in that box. It kind of saves it and it kind of remembers it and it looks after it. And you'll actually find that if you try this right now, if you start your program, write an answer to your question, so type something in and press enter, you should then find that if you go to your block library, you find this blue block called answer and you click on it, it will actually tell you the number that you, or the word or number, or whatever you just wrote in that box should just pop up underneath it. But then if you run your program again and you write a different answer, and then you go back to the answer block and click on it, you should find that it says a different answer. So the key thing is that this block right here, what it means can actually change. But what it means is whatever you wrote in that answer box when your project asked you a question. So it will always store your answer. So armed with that knowledge, what I've got now is a selection of the blocks that we need to make our project work. But I haven't put them together. I haven't filled them all in with everything that they need inside them, because I want you to see if you can find them all and have a go at using them for yourself. So this hopefully is roughly what your program looks like so far. You've got your green flag block and your ask block, but you also need to find all of these other blocks. Some of them, it might be kind of easier to tell where they go because of their shape. But if you have a think through sort of logically what you want to happen and in what order you want it to happen, then that might help. And I think the key thing to point out here is this block here, which is the if block. That's the one that's, I guess it's the most complicated block that we can see on the screen. That's the one that allows us to create two possible options. So we can make something happen when a certain condition is met. So when something is something, then that will happen. But we can make something else happen otherwise, so if it isn't. So hopefully that is enough hints, but feel free to ask further questions and I'll give you a few moments to have a little bit of a play and see if you can get your quizmaster to ask you your question and tell you whether or not you're right. Happy with that? Okay, any questions before we move on? Are we ready to move on? Yeah, okay, cool. Righto, so you probably got something along the lines of this. So this is one version of this script where when I ask my fairy character, or my fairy character asks me rather, what is 3 times 12? What is 3 times 4? And then if I answer 12, then the fairy will say, well done, and it will say it for 2 seconds. Otherwise, so if I say anything other than 12, then the fairy will say, whoops, not quite, for 2 seconds. So that's kind of what this set of blocks means and how it works and why it will make that happen. So you can see me just sort of testing it out a little bit on the screen there. Is that roughly what people got? Yeah. Cool. So the next step would be to add your next questions underneath. And actually, we've done the hard bit now because this is really easy. All you have to do is if you right click on the ask block, you'll get a option to duplicate your blocks. And the way that copying and duplicating works in Scratch is it will copy that block and everything underneath it. So if I only wanted to copy part of my script, then I just have to make sure that I click on the block halfway down or part way down, and I'll get everything underneath it. So for this project, actually, if I want to ask another question, all of the blocks that I use are exactly the same. The only difference is the question and the answers. I might also want my character to say slightly different things just so it doesn't feel too repetitive and robotic. So maybe instead of saying, that's right, well done, maybe next time she'll say brilliant or correct. So I can kind of play around with what's inside the boxes as well. But that would be the next step, would be to copy your blocks and then just fiddle around a little bit and change what it says inside them. So you can have a little play with that if you like, if you want to carry on a bit more. But while you do that, also, I think it's good to always think about what could make something like this better. And there are actually lots of opportunities to have a little bit more of a deep think and include different aspects of maths as well as different aspects of computing into a way of making this better. So for example, you might think that this quiz would be a bit better, it would be a bit more effective and a bit more exciting if it gave us a score. Because at the moment it tells us we've got it right or wrong, and then it moves on to the next question. It doesn't really, nothing really changes. It doesn't actually matter what I said when I answered my questions. So if you wanted there to be a score, then you would need to use something called a variable. And in programming, actually, we've already used a variable really in this project, because a variable is when you give a number or a value a name, and then you use that name in your project when you want to call upon that number, and it can change. It doesn't always have to stay the same. So we already have a variable of one in one form in our project, which is the answer. And the answer is a really good example of what a variable is, and it's a variable that you change by typing in the answer to the question when you get asked it. But in Scratch, you can kind of make your own variables. You don't just have to use the ones that are already built into the blocks. And you do that by going to the variables section in the block library. You can then press make a variable. And then it's always a good idea to name it something that actually makes sense, because if it's just called variable, it can get quite confusing in your code. So you can see in the example on the screen, I called the variable score because that's what it represents. It represents what your current score is in the game or in the quiz. And you can see I've added in 2 blocks relating to score to my project. The first one is set score to 0, and that goes at the beginning, because obviously if you restart your project, you don't want your points to keep on adding up and adding up. You don't want to get more points for the same questions. So that one is like a reset option that sets it to 0. And then you also can add the one called change variable by, or change score by, and I've added that one into the first fork of the if block, because it's what happens if I get the answer right. You could get even more. You could get a bit more creative. You could add another change variable by block into the else section. You could have it so that your score goes down if you get the answer wrong. You could have it so that your score goes up by 3 when you get it right, and down by 1 when you get it wrong. You could kind of play around with those numbers, do all sorts of different things to change the way that your game is scored. But that's kind of how you could use variables to add a score to your game, to your quiz. Another one that you could use, and this is really good fun, is on the left hand side of the screen at the bottom, there is this button that's got a little like symbol. It's like add blocks basically, and if you click on it, it gives you a selection of different like kind of add-ons to Scratch that allow you to do different interesting things. And some of them are collaborations with different tech companies, and actually this one is a collaboration with Amazon Web Service. There's also a translation module that you can add that links with Google Translate. But what this basically does is it allows you to create a box where if you type text into the box, instead of it popping up in a speech bubble, it will actually say the text out loud. So it's got a text-to-speech function in it. So you can see I've used that option in this project so that instead of just having a speech bubble on the screen, I can make my character say, that's right, well done. Or it can say, whoops, not quite. And you can change that each time as well. You can even actually combine text to speech and language, and you could get it to say in a different language if you were so inclined, and translate as it goes along. And then this last one is getting a bit more complex from a sort of computing point of view, but I know I partly included this because something that quite a few teachers have mentioned to me over this last period is that there's a thing happening where sometimes there'll be children that have actually used things like Scratch quite a lot while they've been at home, because it's something that's free and that you can access on a computer. And this might be quite varied. So it might be that there are some pupils that have used it loads and are quite confident, and some pupils that haven't so much. So this is like something that just could be a way of kind of extending learning for those who are more confident, but also possibly something that, because I know one of the things with Scratch is that often, and children do this with their teachers and with their classmates, if a child has learned something that's interesting and complicated, then they always want to share it, and they might want to share it with each other, or they might want to share it with you. And this could be something that maybe a couple of children could have a little go at and then explain to some of the others. So this is creating lists. So we already used one type of one way of saving data in your project, or we've actually used two. We've used the ask question one, which saves your answer, which is a piece of data, and we've used the score option, which is creating a variable for your score. But you could also use lists, and lists is, instead of having one single piece of data, you can create a series of bits of data. In this project, I used one list called questions and one list called answers. And you can see I've only actually I've only put 2 in so far, but I could keep going with this as long as I wanted. And what that allows me to do is create a project where, instead of having to keep copying those blocks and putting the same blocks again and again and again underneath each other, what I can do instead is I can tell my character to reset the score and also reset the question that the character is on. So basically, go to the beginning of the quiz is one way of thinking of set question number to 0. So go to the beginning of the quiz and reset the score, then change the question number by 1, move on to the next question is what that block basically means, and then ask that question. So ask that first question, and if the answer is the same number on the list of answers, so if they've asked question 1 and the answer is answer 1, which is 12, say well done, and if not, say whoops, not quite. Then repeat that process. So change the question number again, go on to question 2, do the same thing. And then if I had more questions, then I could keep on repeating that and make my way through a whole list of questions. So it's one of those things where it sounds more complicated, but actually the script that you end up with is shorter and more simple. And you're really only, you're making a program that does exactly the same thing that your program does. You're just doing it more efficiently. And that's one of the fun things about programming, I think, is like kind of looking for these little ways of making things more efficient, and sometimes that allowing you to think about things a bit more deeply. So before we go on to me, actually, I think probably we'll have a break before we do this anyway, but I'll skim through when we come back from our break a few other ways we can use Scratch and Maths. But does anyone have any questions about any of that stuff we just looked at? I'll stop sharing now. Okay, great. So are we all good? So we'll come back in 10 minutes time, so 10:35. Is that okay, Peter? Yeah, so grab yourself a tea or a coffee, and then we'll carry on a little bit.
Thank you. Thanks very much.
Thanks.
Welcome back. So as I said before, I'm going to kind of talk through a few other ways of using Scratch. Some of it kind of links with some of the stuff that we've already looked at. Some of it talks a bit more about some other things which may link with some other work that you're doing with your pupils. But I won't go into huge amounts of detail about it. However, as I said before, we'll send you slides with links, and a lot of the stuff that I will show you links with sort of template projects that I've made in Scratch, so you can use those projects to kind of explore a little bit if you're interested. Or sometimes it will just have the enough instructions on the slide that I think you can probably kind of work out what to do. So so the first one is this is a bit of a starter activity that I sometimes do with children that are familiar with Scratch but maybe haven't used it in this way before, which is basically to see if you can get your cat to count to 10. Now, the easiest, or at least most obvious way of doing this, is just by using the same kind of speech bubble that you used to get your quizmaster to tell you when you got the answer right or wrong. So it was the block that's in the look section, and it's the say block. You can use that block, but you can put numbers in it, and you can literally just get your cat to say 1 and then say 2 and then say 3 and then say 4. I tend to tell the children to get it to say each number for 1 second at a time, so that basically it takes 10 seconds to count to 10. And that's kind of the first solution that you might come up with to that problem. But now that we've had a bit of a go at using variables, you might also be able to think about how they could be helpful for solving this problem, because it can be a bit repetitive, a bit boring, going back and forth between the looks blocks and the script area and dragging the same block again and again and again. So yeah, so you can use a variable to help you, because it means that instead of having to use the same say block each time, you can use, or sorry, a different say block each time, you can use the same say block, but you can get it to say something different. You can get the variable to change. And you can do that using a program that looks a little bit like this. So you can set your counting variable. And I actually did a bad job when I made this example, because I just left it called my variable, which is not very clear, is it? It's not very easy to tell what that variable is actually for. I could have called it something like counter or count. So then I set that variable to 0 at the beginning, but then each time I want to count, I change the variable. So I go one bigger, and then I say the number that I come up with, or the variable. And so using this basic structure, there are all sorts of things that you can do that involve manipulating those numbers differently. So for example, how would you change this basic structure? There's one very easy thing that you could do, so that instead of just counting to 10, your cat counted to 100. So you can change one of the numbers in this, and that will make that happen. So that's going to be the repeat number in this project. So if this was repeated 100 times, all that would happen is it would keep on going until it had done this process 100 times, and it would count to 100. Could you get it to recite the 12 times tables? Well, if it's reciting the 12 times tables, then instead of going up by 1 every time it counts, it needs to go up by 12 every time it counts. So that means that that change variable number is going to need to be number 12 instead. Could you count down from 70 in sevens? Well, one part of that we've already thought about a little bit. Counting in sevens would involve changing this block, the change my variable block. You'd actually have to use a negative number because you're counting down. This change block, what it really does is, from a kind of operations point of view, it when it says it changes the number, it really adds to the number. And that means that if you want to subtract from the number, then you have to add a negative number. So then you could change that number to a negative number. It would be -7 in this case. But obviously, if you did that, then you'd also have to make sure that you had set your initial variable, your counter, to a higher number at the start of the project. And actually, you might initially try 70 when you do that, but you would quickly find that that doesn't quite work, because it means the first thing that your character would say is 63. Because it changes it before it starts speaking. So for this example, you'd actually need to set your variable to 77 at the beginning. And then that last one, ask which times table you find hardest, and then help you with them. That's going to involve using the ask and answer blocks that we had a go at using earlier on with the example project. So as I say, I have put an example of what that project might look like if you followed it through. And this is an activity that I've done with children before. And just as like before, I think one of the nice things about Scratch is that there are always lots of little ways of extending activities. So that last bullet point there is not something that you'd necessarily do with every class, or even with every child in any one class. But it can be a nice little extra challenge that you can give somebody to kind of nudge them along and get them thinking differently. And then maybe that they can share with the class as well. So that's one way of, or another way of using Scratch. The next one I wanted to mention was about patterns and geometry. And this involves using blocks that are called the pen blocks. So earlier we added, or I showed you how to add the text-to-speech blocks from that section at the bottom. And there's also one that's called pen, a set of blocks that are called pen. And when you add those ones in, you get these green blocks over here, and they allow you to do all sorts of different things to do with drawing in your project. Essentially, you kind of have to imagine that every single character in Scratch is holding an invisible pen with it wherever it goes. And that only makes any difference to what happens in your project if your character puts its pen down, because that means that when it moves, it will actually leave a pen line behind it on the stage. And so you can use that fact to tell your character to put its pen down and then move in a specific shape, and it should leave a pattern behind it, that depending on what instructions you've given it. So an activity that we might do in relation to that might be something like, could you work out how to get your cat to draw a square? So it would need to lower its pen, it would need to move a specific amount in a forward direction, it would need to turn a specific amount or specific number of degrees, and you could specify whether that was left or right as well. And then it would probably need to lift, after it had done that a certain number of times, it would need to lift its pen up and stop drawing. So those are the kind of things that Scratch would have to be able to do to make this happen. And then your job in this challenge would be to try and find the blocks that you need to do it and work out how many of them you need and in what order. A repeat block would also make it a bit more efficient, because actually you find that it needs to do the same thing 4 times in order to create a square. And this is what a solution to this problem might look like. Your cat would put its pen down 4 times, it would move, say, and this is just an example, but about 50 steps. In Scratch, steps are actually very, very tiny. So 50 steps is actually a fairly small amount. And then it would turn 90 degrees each time it got to the corner. And this part is really interesting because, of course, when we think about squares, we do think about 90 degrees. We think about them having right angles. So it makes sense that it would turn 90 degrees when it gets to the corner of a square. But in a way, this can trick us into a slight misconception, I think. And that becomes a bit more apparent when you move on to another activity of the same kind of in the same area. So if you were going to apply the same logic to make your cat draw a triangle, you might initially think, well, a lot of this is going to be the same, but it's not going to repeat it 4 times, it's going to repeat it 3 times because a triangle has 3 sides and 3 corners. But it will still move 50 steps. But the really big important difference is going to be this turn number. Now, when you ask children what that turn number needs to be, they'll all usually give the same answer. And actually, when they give that answer, it doesn't quite give the result that they might be expecting. Because usually they will, if they've learned about degrees and angles and they've learned a little bit about triangles, then they may know that the interior angles of a triangle add up to 180 degrees. And they may use that information. And this is one of those things where if I see somebody make this mistake, I'm actually really impressed with their maths. Because if they can use that information, they might figure out that each of the corners on this triangle needs to be 60 degrees. So they may think, I need to put 60 degrees into that block. And when they do that, they won't actually get that shape. They'll get a hexagon instead of or they'll actually get half a hexagon. And then if they click on it again, it will go all the way around and it will do a full hexagon. And the reason for that is that when your character is drawing a shape like this, the important angle is not the interior angle of the shape, it's actually the exterior angle. Because if you think about it, when your character gets to the end of one edge, it's pointing outside of the shape, it's not pointing inside of the shape. So it actually needs to turn that outside exterior angle in order to get to make a triangle. And I think another way of thinking about how you would solve this problem is if you think, well, when my character draws my triangle, how far is it going to turn all together? When it gets back to the start and it's finished the shape and it's gone all the way around, how many degrees in total will it have turned? And that might be an easier way of thinking about how to solve this problem, because actually, if you know that there are 360 degrees in a full turn, then you can think, well, my character is turning 3 times, but in total it's going to be 360 degrees. And then that can help you work out that in fact the angle that you need to make your triangle is going to be 120 degrees rather than 60 degrees. And actually, once you've noticed that pattern and once you've figured that out, you can extrapolate that to all sorts of different shapes. You might have accidentally already discovered that 60 degrees makes a hexagon, and that actually makes sense because 6 times 60 is 360. But you can use that same pattern to figure out all sorts of other shapes as well. And this little activity is actually based on Scratch Maths, which is a scheme of work that was made by UCL, and it was all about teaching maths through programming, as you would expect. And one of the things that's really nice about the way that their activities work is they really build up from you have to really understand what each individual instruction does before you're asked to put it together into something more complicated. And it can really help to help to improve the kind of depth and solidity of understanding before you're expected to do really kind of complicated things with it. But I think here really clearly see that Scratch and programming and visual programming is being used to make something that could be quite abstract really clear and really visual. And also that I think we talked a little bit earlier about that kind of self-assessment and mindset. And I think feeling comfortable making mistakes is really important in programming. And I think it's important in maths as well, because when we show our working, we make mistakes and we show our working and we don't hide where our misconceptions are, it makes it a lot easier for us to figure out what we need to fix in order to get the answer right the next time. And I think that this example is a really good example of where actually the more confident you are and the more maths knowledge you have, the more likely you are actually to make a mistake. But that mistake is really informative and it helps you to solve the problem. So I really like to talk a lot about mistakes whenever I do this activity with children, and try to really encourage them to think about it in that way. And then so still keeping on the pen theme, but going in a slightly different direction. This is an art project, or kind of like a little piece of Scratch art, where I've used programming and used the pen blocks to create this rather more complicated scene, because you can change the thickness of the pen as well. So it doesn't have to just be one thin line, it can be a much thicker line. And you can also change the color and the shade and things like that. And I've used that fact to create a project that draws this palm tree, except actually at the moment this project is a little bit broken, and you'll find if you test it out that the palm tree isn't standing up, that it's kind of on its side. And so the challenge in this activity is to see if you can fix the project and see if you can get the palm tree upright instead of leaning over on its side. And then this next one is actually, this is also inspired by the Scratch Maths resources that I mentioned before. This is, I think in the original resources, it just uses a little square, but I changed it to a strawberry because I thought it was more fun. And basically using those same sorts of blocks and using some repetition, using a bit of mathematical knowledge about rotation. So I've got these 5 scripts and these 5 patterns. And each script makes a different one of the patterns. And the aim of this activity, and this can actually be done completely unplugged. You don't need to create these programs in Scratch to figure out how they work, because it's kind of designed to be a talk activity, really. The idea is that you look at the scripts and you look at the patterns and you try to deduce you try to look for clues that tell you which one made which pattern, basically. And so some of those clues might be to do with things like the colors that you can see in the pattern, and whether or not the color changes, whether or not there are visual effects like ghost, which makes a character go a bit more see-through. But some of them also might be to do with the number of repetitions that occur within the pattern. And the main block that I haven't talked about yet that is used in this one is the stamp block, because stamp makes a copy of your character. So what you can do is you can make a copy and stamp your character, but then if you change the way the character looks and then you do it again somewhere else, that's how you can get these kinds of interesting kind of different patterns. So yeah, so this one can be, if you've got a little bit of knowledge about using the pen tools in Scratch, this can be quite a sort of self-contained little activity. You can start with a bit of talking, but then maybe you can go off and try it in Scratch and see if you can get it to work. And I've actually added a link into the project as an example there. And yeah, Peter, thank you for adding this in. This is the link to the Scratch Math resources, which I've mentioned. I kind of drew upon in the way that I put some of those activities together. There's 6 modules across year 5 and 6, and it really, in a lot of it kind of very careful detail, breaks down activities for teaching maths through Scratch at with those age groups, and it's based on the maths curriculum. So it might be a little out of date because they wrote it a few years ago, but it will still very, very closely align with what you'd be teaching at in those age groups. The only thing I'd mention about it is that because it was created for a research project, the resources are like almost information overload. It's almost like there's just too much information, and it's very prescriptive about how you would teach it. But the only reason for that is because it was research, they wanted to make sure that there was consistency in how it was being taught across the schools that were involved. So just be aware there's quite a lot in there, and you might find that you want to just cherry pick bits that are relevant and that make sense to you. But because the resources are available as PowerPoints, you can quite easily you can like pick and choose what you actually want to include in your own teaching. But that's just a really good resource that I thought I would mention, and I'd recommend having a little bit more of a look at. So I hope that whistle stop tour of quite a lot of different things that you can use Scratch for was interesting. And as I said, if you have more questions about it, we can come back to it at the end if we have time, or just email me and I'm happy to answer any questions about it.
So the next 2 sections, I guess they're related, and people have already been mentioning manipulatives, digital tools. So a little bit of a section on that, and we've come across a useful collection of links, but it may be that you are aware of all the resources on that PDF that we've got, but I've just picked 2 or 3 to show. And then if anyone's at a computer where any of your favorite manipulatives are to hand, you could screen share if you would like to. So this is a kind of fairly informal session, and then a little bit on digital platforms as well, and maths platforms. So I've got a couple of questions for you as well. So I'm just going to share my screen again. Yes, so my first kind of incidental question, because I came across these resources on the ATM website, is I was just wondering if any of you are members of any of the maths subject associations, or you get a chance to see what they're up to.
Yeah, I'm not a member, but recently I've dived into the world of Twitter, and all of those things are constantly updated on there. So I do have a good look at what some of them offer.
Yes, I'm well aware. Thank you very much. I'm well aware everyone has limited time. So, but I've realised there's a whole wealth of quite recent stuff out there as well. And yes, several of you were talking about manipulatives. I think Billy mentioned MathSpot, and SEN, and Jack, you also mentioned MathSpot. And as a teacher of a certain vintage myself, I remember the kind of heady days in the early noughties when web-based resources weren't so easy to access, but there were some programs at that point, things like GeoGebra, which is still around and still has got lots to offer, I think. And then with the national numeracy strategy coming in, there were the kind of first attempts to get schools to wholesale make use of what digital resources could offer. And there were some really plain and austere programs that you could download called the interactive teaching programs, ITPs, and they were just blue and white, but quite functional. And I don't know if any of you might remember those, but things have moved on an awful lot, and things are pretty engaging now and so useful. So sometimes they're called different things. Manipulative seems to be the latest. So there's resource PDF, and I've just picked out 3 examples. Enrich has been around for a long time. I hadn't seen Toy Theatre before, and Mathigon I've not had a chance to explore at all, and it looks like a really rich source of nice materials. So I was just going to quickly bring some of those up on screen. Let's see how it goes. Some of you mentioned doing investigations and problem solving. So tangrams are a classic that I'm sure many of you have worked with in the past. They might even have featured in one of our previous sessions. So this is only one tangram resource online. So Toy Theatre, it's got a little bit of background, various options. So you'll see the idea. So quite plain and simple. I started to explore the area and perimeter tool, and I thought it was quite nice. If you've not used this before, it does, as you change the number of blocks, it updates the perimeter. You can hide the perimeter. You get the idea. Geoboard again. Don't know if geoboards are around still in classrooms. Great. So again, an on-screen version with some tools down at the bottom. So that was Toy Theatre. Lots more in that as well. Enrich you may have used before. Lots of resources there. Fairly simple once it loads. Some virtual dice and spinners and options that you can choose there. So that's a straightforward one, I think. And then, oops, Mathigon. I followed the link to Polypad to start off with. So really nice, bright, appealing resources, but on the main Matagon site, lots and lots of sections that I haven't had a chance to explore, but I did like the timeline of mathematics as well. So has anyone come across that before?
Yeah, if you go to activities, they've got a really good little problem solving section actually. Got some great, especially for year 6 teachers out there. It's quite challenging, but I think every Christmas they do like an advent calendar of math problems. I think it's just down a tiny bit. Yeah, problems and puzzles, that's the one. And then it's got the past 3 years worth of advent calendars worth of little math problems. And I think you need to log in to find out the answers, but some great ones for children to have a go at.
Yeah, looks like very extensive resources, and I really like the nicely designed presentation as well. So that's Matagon. So do you have any favorites, any other favorites that you'd like to contribute to this section?
Transum is a good one. Transum's got some good games on it. So I've just been putting together a Padlet of all the math resources. So literally, yeah, I've got tons. But yeah, Transum is one I quite often use in lessons as well.
And I should probably mention that the source of the PDF is on the Mathematical Association website. So it's a meeting this year of people pooling ideas for resources, and on that PDF down at the bottom as well, there are some big list of ideas for home learning activities as well, where there's no access to other resources. So let's hope we won't have to use that, but thought that was a really useful collection. So let's go on to the next section then. And this isn't an exhaustive collection of what's out there, but there are a number of platforms that some of you, I'm sure, will be aware of that happen to include a lot of maths content, activities, or maybe tools alongside other resources. So for instance, a platform like Purple Mash that some schools use has got a collection of maths games and other tools and activities too. And then there are some very specific maths platforms, some of which have been around quite a long time now. So we're just going to have a quick discussion in case you've got any observations. Another Padlet for you to spend a little bit of time, maybe to have a look at some of those websites, see what you think. If you have been using any of the specific sites, maybe not this year, but in previous years, please do put in any comments about your thoughts. And then if you get a chance to look at something that you haven't seen before, your first impressions, and then Rowan's going to lead a section later on, so you might want to think about, is this of relevance or not? I know the biggest constraint for most schools will be budget, because some of these platforms are subscription based. So this is just a selection of them. Seeing those names there, would anyone like to mention anything that they've used previously?
We currently use Mathletics at our school. We tried SumDog. I think it was quite new when we tried it, and yeah, unfortunately we end up sticking with Mathletics, but we use that fairly regularly and they seem to update it quite often. So the children quite enjoy using Mathletics.
I know that for schools that have got budget, it's quite a competitive market. So all of these platforms have been kind of trying to keep up with things. I know Manga High is one that's been around a very long time, as has Mathletics. And then some of them, like Learning by Questions, have a certain amount of free resources because that's backed by a Boland charitable foundation, but others, as you know, are subscriptions. So if you wouldn't mind spending just a few minutes on the Padlet, add a post with your observations like that, or a comment if you get a chance to click on the links and get some first impressions. And yeah, we do take it for granted that you may not have budget. And if there are some other tools or platforms that we haven't mentioned, feel free to post those on as well. So the Padlet looks something like this. So it's got some possible prompts along the left-hand side, but that's entirely up to you. And then each one of those has got a link to the website as well. So pick whichever ones you're interested in or you want to choose. And maybe if we have 3, 4, 5 minutes on this, please feel free to add any comments. And then there's a section at the end for any other suggestions that you'd like to share. So you can either add a post if you want to click on the plus, or those existing posts have got room for comment as well. Entirely up to you. Yeah, thanks for the comment about early years, because we haven't so much mentioned that in this session. And some of these sites are Key Stage 2 and above. So good to know about. Thanks for those comments that are going on, maybe just a minute or two longer. And as we said, if this is something that's useful to you, then you'll be able to access this afterwards, should you wish. Okay, thank you very much for that. As you will have gathered, there are different types of platform there, and increasingly some of the platforms offer adaptive responses. And just to mention that London CLC, we're in an Erasmus project called Empower to Learn, that's kind of in the middle of its 3-year project span. And as part of that project, we're looking at platforms that have got an AI element, that are responsive to learners. And the main theme of the project is personalized learning. So increasingly platforms are offering that. And I just wondered at this point whether any of you have got any thoughts about these platforms, and whether you might or might not want to be using them in school, any advantages you can see. Are you happier sourcing your own resources, putting things together? Any thoughts on that? What are the benefits of a platform? Pros and cons?
I think one, like you said before about the cost, I think that is something you need to, well, I would have to do a lot of justification or justifying for us, to actually buy into the program. Yeah, we wouldn't even buy into White Rose, for example. So I think it would, quite dependent on the school too.
Yes, that's entirely understandable.
We just started using Atom Learning, which is like an adaptive thing, verbal reasoning, non-verbal reasoning. Very good for like children that are ready to sit exams. Again, it is a cost though. The only thing I would say is like then use year 3 and year 4. I don't know if the algorithms are quite right yet, because not enough children have answered enough questions. So when they are doing the adaptive learning, I do get a few parents saying, oh, it took them a little bit higher than I was expecting them to go. So, just with a few of those adaptive learning websites, I think it needs numbers for the algorithms to work out where the children should go to next. But I think in the future, they're going to be pretty popular with parents.
Yes, indeed. And I noticed that some of these platforms have had a home learning offering for parents as well. So I guess that kind of raises the interesting question that one of you mentioned earlier about finding out how much the children are actually able to do themselves with or without support as well. So thanks for that.
And that brings us to the end of this forum on using technology to support maths in a blended setting. For more self-paced courses and recorded webinars like this one, as well as some live CPD sessions, you can visit the Learn section of the Blended website. For updates on useful resources and ideas from our community of educators, follow the CLC on Twitter or sign up to our newsletter by visiting londonclc.org.uk. Thank you.